Hello. Our second review topic of the week is on the difference quotient. So this is just doing the difference quotient for polynomials. So the difference quotient becomes very important when we look at finding the derivative and using the formal definition of derivative, which we will get into early next week. So what is the difference quotient? So early on in the year, we looked at it, and it is f of x plus h minus f of x all over h. And what this gives us is that this allows us to find the slope of a graph of a tangent line at one specific point. So when we establish this, we're looking at an h value that is really small. So let's do an example. If f of x is equal to 3x squared plus 4x, we want to evaluate the difference quotient. So one of the first things that we need to do is we need to find f of x plus h. So f of x plus h means that we are going to put x plus h where the x is. So that means we're going to get 3 times x plus h squared plus 4 times x plus h. Now, one of the biggest issues is that people have a tendency to multiply in the 3 first before multiplying out x plus h. So as a little side bit, we're going to do x and then plus h, and then x plus h in the multiplication. So that gets us x squared, and then xh, then another xh, and then h squared. So that means x plus h squared actually gets us x squared plus 2xh plus h squared. So that is the value that we are going to put in the parentheses. So x squared plus 2xh plus h squared. The rest of the equation is going to stay as is right now. So 3 and then the parentheses plus 4 times x plus h. We're now going to go ahead and do the distributive property. And when we do the distributive property, we're going to multiply in the 3. And then afterwards, we're going to multiply in the 4 as well. Okay, so what will that get us? Well, that will end up getting us 3x squared plus 6xh plus 3h squared plus 4x plus 4h. We're now going to use these values, and we're going to substitute both of these back into the difference quotient. So this entire f of x plus h is going to go into the first part of this equation. And then the second thing, the f of x, goes into the second part of that equation. So this is going to get us, our difference quotient will end up being, the first equation is 3x squared plus 6xh plus 3h squared plus 4x plus 4h. Then we are going to subtract the whole original first equation, which is 3x squared plus 4x all over h. At this point, we can distribute out the negative, so that gets us 3x squared plus 6xh plus 3h squared plus 4x plus 4h minus 3x squared plus 4x minus 4x. Make sure you distribute that negative to both of the pieces, so minus 4x all over h. So now what ends up happening? Well, we are going to cancel out our like terms. So 3x squared and negative 3x squared cancel, positive 4x and negative 4x cancel. So what does that leave us with? Well, at this point, we are going to have 6xh plus 3h squared plus 4h all over h. So the first thing to realize again is that everything in the numerator has an h in it. At this point, we're going to factor out the h. If we bring out an h, we get 6x plus 3h plus 4 all over h. And then our last step is to cancel the h on the top and the h on the bottom. So that gets us a difference quotient of 6x plus 3h plus 4. This value with the h in it is the difference quotient. Now the other thing that we did, which on your homework tonight, this will not be part of it, But we also then we said we want to evaluate when h is equal to 0. This is going to be one of the things when we actually find the derivative. So when we put in a 0 for h, we get 6x plus 3 times 0 plus 4. The 3 times 0 cancels out, and it leaves us with 6x plus 4. Now, when we have that, we're going to do more information with that a little bit later, but hopefully this is a good review of the difference quotient.